Hello, everyone. We are continuing where we have stopped after the marvelous keynote sessions delivered by Jovan Marjanovic, who is director of of development of Government Blockchain Association, who talked to us about reinventing data analytics, dealing with legacy, as well as Prasanna Lazdas, who is a lead data strategist at World Bank, who talk about importance and culture of data policy around the world. We are continuing with our stream, as you may know because you're listening to this stream. This stream is business application of data and AI. Basically, we had 3 lectures so far, very interesting, inspiring lectures delivered by Alexei, Georgi, and as well our last speaker, Pavel. We're continuing and moving forward, and our next speaker is Tamas, and he is going to talk about money talks, real-life anomaly detection and subscription data. Basically, what I'd like to say is that monthly recurring revenue is the most fundamental indicator of the financial well-being of startup and scaled-up subscription-based businesses. Unfortunately, this metric is not a well-behaved one, as I may say, in the data analysis aspect. There is a trend in it, and it can be exposed to seasonal campaigns. In this talk, Tamas is presenting how to decompose it to elements and set clever early alerts on them, saving valuable weeks for your stakeholders to act in case of emergency. Basically, MLNet does not seem to be a trivial choice in the Python data domain, but he had his own reason to choose this framework, and he will explain to us why. Last but not the least, Tamas is an experienced product data analyst from Budapest, working at Bitrise, a mobile-first continuous integration delivery software as a service provider. So basically, Tamas, you have a floor. I hope that this introduction was good enough and explained everything what it needed to explain.
Thank you for the introduction, Alex. Welcome, everyone. Good afternoon. I hope you had a delicious coffee. And as you already heard, I'm working at Bitrise as a data analyst. And first, let me introduce Bitrise in a couple of slides or sentences. Bitrise is a CI/CD solution specifically for mobile application development. If you've heard Colin's presentation, you're already aware of how many different ways you can apply CI/CD processes. What Bitrise is doing is, and where Bitrise can help the fellow developers, is that we are providing automation for repeated tasks like code signing, testing, building, deployments, and applications are the results of a complex development process. A CI/CD solution is to help the developers provide to cooperate with each other, ensure that the code is faultless and released on time. So basically, you have a code base on GitHub or Bitbucket or GitLab, whatever, name it, and you attach this repository to Bitrise. You create your workflows. For example, you would like to test the application before deployment, set triggers on it. For example, somebody's opened a pull request, would like to merge the different branches of code, and then there should some tests happening or deployment process starts up, so on. Bitrise provides the integrations out of the box, like deploying Google Play Store or Apple App Store, Apple iTunes, adds the infrastructures and runs the builds for you of your workflows, that what you've defined in the YAMLs you saw in Colin's presentation. In the agenda, I promised talk about money. So let me talk about how Bitrise makes money. Bitrise makes money like Netflix or Spotify. That basically we get subscriptions, and the money we make is based on the new subscriptions, the canceling subscriptions, the upgrades or the downgrades. These last two is about the quality of the subscription you have, how many concurrent builds you can run, or how many team members you can invite. But high-level decision makers are usually interested in one or maximum two figures, but not four different ones. They would like to have a compressed view of what's happening in the business. And the figures we use for that, and most subscription-based businesses using that, is the annual run rate. The annual run rate tells us that what is the recurring revenue we can expect at the moment for the next 12 months, and in case nothing has changed. So it's not a projection of the current or recent growth, it's a projection of the recent recurring revenue. Monthly recurring revenue is basically a similar figure used for 1 month. And this is the number of customers multiplied by the average billed value. ARR and MRR, annual run rate, and monthly recurring revenue tell the investors how much money the business can sustainably make. Not at the moment, not in the future, not due to marketing campaigns which are just increasing the revenue one time. This is showing out, or these two figures are showing out that how sustainable the business is. When we were looking at the ARR and MRR figures this spring, that we had to recognize, and unfortunately we only recognized it in somewhere middle of May, that our MRR figures were a bit hit by the lockdowns, by the uncertainty and the economic slowdowns of our major markets, the US and Europe, and basically all over the world. The question we raised, of course, at data, that how can we capture, can we capture this issue a bit earlier? Could have been this issue being captured. To answer this question, let me show you the desired curve or desired shape of the monthly recurring revenues. Basically, as time goes by, you should increase the monthly recurring revenue. It's simple, that every kind of business would like to earn more money, and the investors also would like to, at some point of time, would like to see their money back. But we analysts don't really like these charts. It's a nice chart. As the time goes, we're getting more money, we are richer, but this is not the one that we like. So let me show you what analysts like, so what kind of curve or shape they would like to, something like that. Of course, it's not money, but it can be anything. It can be puppies or unicorns. If you get one unicorn today, you're happy. If you get still one unicorn tomorrow, that you're still happy. But I will go back later. Let me come back later to this chart and introduce some maths, just basically high level. You already heard in this conference that, I don't know, some 20 or 25% of the software developers are already data scientists. I'm not there yet, but let me show you what the maths of these subscriptions. MRR is by definition autocorrelated, that we are interested in the recurring revenues. A subscription is not happening for 1 month. The subscription is auto-renewed each time until each month or years based on the type of the subscription. But basically, that if we have X number of subscriptions, probably the next month we will have something close to X. So our observations are not independent. They can be determined by the function of the former figures. For example, the growth rate can tell you, multiplying the growth rates of today's MRR, we will have the tomorrow's MRR. If the business is growing, MRR is basically, it means that it's not stationary. The average of the sequential observations in a specific time frame increase over time. So it's just a description of what I've shown you, that we've got an increasing trend in the monthly recurring revenue if the business is healthy and growing. The issue is that we can't spot trend shifts on time. So if my business is growing 5% a month, is the current 4% an issue? Or is just a one-time issue? Or maybe it's not just an issue, it's just a seasonality. This is summer, there could be holidays, so on. So how a good time series looks like or behave, that we analysts like the independent and identically distributed i.i.d. processes. Independent in terms of all observations don't affect each other. Identically distributed, there's no overall trend in that. Let's take an example, the dice, that we are rolling the dice. If we win, or even if we sequentially win, it doesn't tell us nothing about the probability of winning the next game. So this is an i.i.d. process. It gets a stable expected value, and its variety remains the same. How can we determine if a process is i.i.d.? If a process is i.i.d., we can take samples which remain exchangeable. So you can do it randomly, but for the sake of simplicity, let's take two different time frames, sequential observations in time, and check that how they relate to each other. So if our process is i.i.d., the subset of the sample of observations are exchangeable. So this is something we already see, that as the time went by, our business grew. So we are making, at this point of time, more money than in the former set of observations or former time frame of investigation. So this is how our business grew in terms of MRR in the first period, and then we get a lower growth in the second period as well. So this is definitely not an i.i.d. Because we've got an increased average of the observations, and also the deviation also increased. So far we learned what is MRR, the monthly recurring revenue. What is ARR? It's the annual run rate. And we know that they are not really helping action on time. But we've got a tool, the exchangeability or investigation of exchangeability through mathematics. We need to find the earliest point or pattern broke. So the question still remains that if COVID hit, or any kind of disaster or just unfortunate circumstances has an effect on our financial figures, can be spot earlier than MRR would indicate. So the question is how we can check this exchangeability on the fly. Let's play another game. Let's say that we are playing darts, and on the vertical axis, you can find that how much point we got by each throw, and on the x-axis, on the horizontal axis, it's the time, is the sequence of thrown darts. So first we make, let's say, 5 points. I don't know, it doesn't matter. The second one is slightly higher, and then the third one is a bit lower, but we've got some kind of pattern that we can get an understanding of how good darts player we are. And then after a while that we see something suspicious of slightly lower, but it could happen anything. You could have a bad day, you could have a bad moment, it can be a holiday or whatever. So it doesn't mean that our trend is shifted yet. We are still the same good players, right? What happens if we are throwing something off the table, so 0 point, and we are still a good players? Is it still the chance? And then we see that maybe there is a broken, the pattern is broken, there is some kind of shift or change in the process generating this time series. Martingale is used to be a bidding strategy, basically saying that if you lose, you double your bid. That you will never be on a negative in the long term. But it's easy to recognize that you need unlimited funds to play this game. So why is it important, or how it goes to darts or MRR or any other metrics? Why is it important for us that how people lost their money in the 18th century France? Basically, this way of bidding can be a model for a charge score called Exchangeability Martingale, which is a function of violating the exchangeability criteria. If the observation is out of the distribution we've got a higher value, or value is exponentially higher for the higher discrepancies, and the sequential scores are multiplied. This means that our Exchangeability Martingale score will lift off in case there are multiple sequential violation of the exchangeability criteria, telling us that the process generating the time series changed. I suppose that is still a bit confusing, so let's go back to the darts example. So I'm still throwing, and I would like to set expectations based on the former 4 points I got. So based on these 4 throw I made, that I can have an understanding of, let's say that I expect the dart somewhere here, right? And let's have a pretty simplified exchangeability martingale function. Let's say that we take the distance from the upper or the bottom limit of the expectations. Then if I'm not failing this expectation, let's take the square of the difference. So I threw something and the difference is 2 points. The current throw is 2 points lower than the lower one that I've expected based on the former 4 figures. So my martingale score, current martingale score is 4. The next time I take again 4, the former 4, so I lower my expectations and think that, okay, that maybe I'm not that confident player anymore. Maybe I'm not that good player anymore. And then again, I throw the mentioned off table 1 and receive 0 points. All martingale score in this case, as let's say the difference is 5 based on my lower expectation. So I even perform poorer than my lowered expectation. So my martingale score will be 5 squared multiplied by the former 4. This way, we can have a score that if I'm violating this exchangeability, if the pattern changes, this martingale score starts to lift off. So back to our figures after pub sports, and check how the financial figures or the metrics defining the financial performance or subscription-based business or i.i.ds or not. Annual run rate is definitely not independent and identically distributed. Same goes to monthly recurring revenue, because they are they usually show a trend and they are lagging. Usually based on the former figures, But if we are taking a look at the new subscriptions, the daily new subscriptions, or weekly new subscriptions, or the weekly cancellations, the weekly upgrade events, or weekly downgrade events, we can find that they are more or less i.i.d. Of course, if we got a marketing campaign, we can attract new subscribers, and the new subscription should show a trend. But if it's a one-time campaign, it will be just a one-time peak, and then it will be back again. So in normal cases, these are more or less i.i.d, more or less noise-like processes. The old solution that what we've implemented that got the daily subscription data, cancellations, new subscriptions, downgrades, upgrades, MRR as well, aggregated on weekly totals to cope with or overcome with weekly seasonality. Of course, we've got lower subscriptions in the weekends, so we would like to have the same number of weekdays in each period. Applied the Exchangeability Martingale based on the former 4 observations. Of course, we used a much more sophisticated formula than I'm showing in the example. And we found that although we've received or recognized the issues of COVID or the poor financial figures in the week, in the second week of May, we were looking at these figures. We were receiving emails from that, but still it was lagging because normally we looked the differences based on 30 days. That how are we performing relatively to the former 30 days? And also, if we would look at weekly or daily MRR figures, it's still auto-correlated. The new subscriptions doubled in April. The downgrades headed north in March. And the lifetime value, which is more of a combination of the former metrics I'm showing, is started decreasing even earlier and somewhere end of February. So the real dates that we recognize that, for example, that we had no alerts. Implementing this Exchangeability Martingale based alerts and we investigated the backdata, we recognized that the weekly MRR growth rate wouldn't throw an alert at all. The weekly MRR growth rate relatively to the last figure would be spotted in April, the weekly new subscriptions in early May, the weekly churns cancellation would have been spotted at the middle of April, and the weekly upgrades, there was no alert because the upgrades are not that frequent events, and probably there was no change in that that pattern or process. The downgrades, which were increased a bit. So, for example, users having a developer license went back to the free one, or they reduced the number of concurrencies. This tendency would have been spotted in April. And the weekly lifetime value, as I mentioned, this is the average MRR corrected by the churn rate. So more or less a normalized and complex indicator. This would have been spotted late February. And a couple of sentences about the engineering, because it's a data science job. It's a part of the data science job as well. So we've got a small application sitting in Heroku. This is a ML. This is a .NET Core application utilizing ML.NET algorithms and populating a PostgreSQL databases where we set up alerts in Metabase and it's sending to Slack. Why we opted for ML.NET is because of this i.i.d change point detection algorithm, which was pretty robust, showing us very good figures, and we could concentrate on the development and not on the maths as well. As I mentioned, we are some kind of data lazy data scientists. So we were concentrating on developing and applying our solution. So I hope this little model showed you to implement your own anomaly detector and time series. It could be, I suppose that this technique could be applied not only on subscription data, but only on any time series. And if you need to implement something, I would recommend to check out ml.net, because that is super good. There are super good built-in algorithms, so you can concentrate on your development. Thank you for your attention.